And we are recording. Excellent. Thank you very much for reminding me about that in the chat room so we don't lose another recording. Okay. Can I make myself a little louder? I guess maybe try to turn up your volume, but I don't seem to have a microphone volume setting. So I'm going to be talking a bit louder in a minute. Okay, so I think for today, I'm going to start with a little bit of neither. And I'm going to give just a little bit of a primer on, this is screen sharing, not just the slideshow, right? Is everyone seeing Microsoft Paint right now? Just confirm with hands raised. You're seeing Microsoft Paint over here. I'm coloring with lines. You guys see that? Okay, thanks. All right, so I just wanted to discuss a little bit some general knowledge, some general education, so to speak, about the internet and how the internet works and how you guys are making websites with HTML, with CSS, with JavaScript. This is not really going to go so much into the back end and the more advanced programming stuff that we're going to jump into. This is really just general knowledge that just helps put things together with like, how does it work when you make a website? How does the browser work? How do the HTML, CSS, and JavaScript files work? And it helps understanding how you set up a website and how your website behaves from one file to the other file, going from an HTML to a CSS to a JavaScript. So let's just cover a little bit of that, and then we'll have some time probably to recap some more basics of HTML, CSS, and of course a bunch of JavaScript, and maybe even some jQuery as much as we can. But now let's start with this. Until now, you guys have been practicing your programming on your own computer at home or whatever it is, laptop or whatever. And my art skills are obviously not the best, and I did not spend enough time looking for some good images online. So I'm doing this all impromptu as we speak. Oh, I accidentally deleted that. Anyways, the point of the matter is you guys were practicing your programming on your own computer at home, so to speak, and you wrote files that exist on your computers. So files and folders is something everyone, I think, understands pretty clearly. It's pretty straightforward. You have, you know, a folder on your computer, and inside of that folder, you know, you can double click it, and inside of that, you might have a bunch of files, and you might also have another folder inside of that folder. And in there might even be some other files, etc., etc. This is your own local file system. You have a hard disk inside of your computer. It has data in there. It has files. It has all of your whatever photos you have on your computer, whatever videos, whatever documents, any of the things that you downloaded over time, right? This is all on your computer locally. It's not on anyone else's computer, and they don't have it. You have it on your computer. And by you having a file on your computer, which you named .html and .css and .js, and by double-clicking on that file on your local computer and opening it up in your browser, that's how you are able to have a web page happening up until now. That's how we've been doing things until now. This is not how the internet actually works, as we know, because, for example, here's one huge difference. I'm going to go ahead and open up our little local website over here. Where is this here? Just a second. All right. Okay. So the first main thing that you can notice here is the address, right? Usually, if we're going to a website, it's like www.something.com or something like that. But here you can see clearly we are at a local file on my local computer. In fact, over here, instead of it saying something like secure or HTTP or web or something, as we see in other websites, oh, here it says not secure because it doesn't have HTTPS. Over here it has a little lock symbol, which means that it has HTTPS. That's not important. You don't have to worry about what that means, secure or not secure. But here it says altogether something else. It says file, because this is not a website on the internet. This is a file on your own computer. And you can see the address of the file is in a folder on my computer. This is in the C drive Oh, actually, if you click on it in Chrome, you can see the whole protocol. A normal website uses the HTTP protocol, which we're going to learn about momentarily. But here, we're using some other protocol, file, ://c, users, my username on this computer is HP, and desktop, and CHYE coding. You know, we're inside of this particular folder, and we're opening this particular file, which is on my local computer. So first of all, this looks very unprofessional, right? You don't want to have anyone browsing to a website that's like at some sort of local address, but also no one else can browse to this local address because only you have it on your computer. This is something that's on your own computer. No one else has it. The whole idea of the internet is that it's something that everyone can access from their browser because it's out there on the internet. So I'm going to try and clarify a little bit what is the internet and how it works, and what does it mean that something is out there in the internet so everyone can access it. So let's figure out a little bit about what is the internet. And actually, as you might realize, or as I hope to show you guys, it's not that scary, actually. It's not that terrifying. It's actually a relatively simple concept. The concept of the internet is basically that here we have a computer, and I'm going to resize it a little bit. And I'm going to make a copy that I'm going to resize somewhere else. Okay, this is pretty much the whole idea of the internet, like pretty much quite literally. Here is one computer over here, okay? And let me make it just a little bit more like this. Here's one computer, and here's one computer, and the whole idea of the internet is just that they can communicate together. That's all it is. And literally, at the very beginning of when they started making the internet, it was literally just the idea of take a wire, figure out a new peripheral of how to connect it to this computer, and pull the other end of the wire and plug it into the second computer, and now start seeing if you can send little bits and bytes of information between each other. That's pretty much all it was. I wouldn't be surprised at all if the first time they tried this in like 1964 or who knows what, 1970, whatever, and the big geeks were sitting at the big computers over there that they were trying to hook up to each other, and they literally were just sending each other things just to test to see if it works, and they wrote to each other ABC. You know, let's make this a little bit larger for illustration purposes. ABC 1, 2, 3, and the whole test was just to see if does the other guy see that text coming up on his screen, and it like went through the wire or whatever, and it comes to this guy, and he says, "Hey, I got ABC 1, 2, 3. Now let me send you something back," and he wrote, "Hello world" or something. And then the whole idea is just like, okay, does this internet concept work? Can we make it go through the wire and it comes to you? Do you see the words? Yeah. Oh, hello world. Very cool. So we're able to send pieces of information to each other. We can send each other letters, numbers, pieces of information. Well, that's cool. That's a cool, nice trick that we invented. I wonder if this could be useful. Maybe we could make some use out of this. Imagine we want to exchange to each other contact information. So I'll send you a phone number over this little wire we created. And then you'll have the phone number, which otherwise you wouldn't have. And then maybe you'll send me someone's name and address or something, and then I'll have it, which I didn't have it before, and now I have it thanks to the fact that we connected a wire and we sent each other information. That's pretty much the whole idea of the internet, sending each other bits and pieces of information. Then eventually they figured out, hey, this is cool, this works nicely. How about sometimes I have a document or a file on my computer, and we need you to have it as well. So not just sending each other little phrases of like ABC 1, 2, 3 and hello world. How about we program this little piece of software that takes an entire file, actually, and the whole entire file, which has a lot of ABC 1, 2, 3s inside of it. It has a lot of jumbles of letters and symbols and stuff, whatever it is, if it's a PDF file, or if it's a document, or if it's a HTML, or it's a text file, or whatever it is. It has a lot of stuff inside of it. Can we figure out how to send this entire file over the wire to the other computer? And that's basically the idea. They're just like, hey, we can send each other files now. That's pretty cool. I can send you a file. I can receive a file from you. That's very cool. And then along comes a third guy and says, hey, you know something? I'm in the University of something or other across the state. And I like this idea of the internet as well. Can I join in on your guys as well? Can I like make my whole entire setup over here? And hang on, where is this? Here, can I also make a setup like this? And then I can get my technicians to hook up a wire. Oh, hang on, I'm doing the wrong colors here. Yeah, whatever, you guys get the idea, but I'm just having my little fun over here coloring basically at you guys' expense. Yeah, and you know, let me connect to the wire as well over here. Okay, cool. So now we can exchange information between each other between 3 different computers. That's nice, that's cool. Wait a minute, how are we going to know who are we sending something from and who is getting it from who to who? If I send a phone number and I specifically want to give it to this guy on the right, but not that guy on the left, how do I know who it's going to come from, who it's going to go to? We need to have a way of how to make some sort of addressing system where we have addresses, like your identifier number is 1, your identifier number is 2, my identifier number is 3. And now each time we send a message, we have to identify ourselves. I am number 3, I am sending a message to number 1. I am number 3, I'm sending a message to number 2. I am number 2, I'm sending a message to number 1, etc. And we need to program this into the wire that it should know. If it's asking to go to Mr. 1, it should go to number 1. If it's asking to go to number 3, go to number 3, etc. So everyone assigned to each other a number. And just for simplicity's sake, eventually, after enough computers got connected with these wires one to another, they needed a lot of numbers to distinguish between different computers. So they came up with this thing called an IP address, which is basically a bunch of numbers that identifies your particular machine. And it looks something like 123.456. Oh, actually, I don't think it could have the higher numbers. I think it's only up to 255, I think. So 233.196.67 or something like that. Okay, so this is my address, all right? Anytime there are messages flying around on that wire, which are addressed to this particular address, then this is the location it needs to come to in order for it to get to its correct destination. Otherwise, it's going to the wrong person. They're not going to know what it's about, what it's for. So anyone that wants to come to me has to use this address. Okay, so, and what's my address? Okay, so maybe my address is something else. 111.222.33. No, there's no 333. It's only up to 255. 222.101 and 44 or something like that. That's my address. That's it. You guys get the idea about this. And isn't this cool now? We can send each other a bunch of information across a whole bunch of wires. And this information comes from anyone and it goes to anyone. But remember how in the beginning, we used to just, life was so much simpler in the beginning. We just typed each other some messages, some text. Hello world, ABC123. And we even got more complicated and we sent each other entire files. But now things are more complex because now each time we send each other a message, you have to encode that message with some special parameters. It can't just go with regular, just here's a file, because who is this file supposed to go to? And who is this file coming from? So after everyone has their address, now things work a little bit differently. 100, 200, 211, 68, whatever. I don't know why I'm only doing 2 digits at the end. It could even be 3 digits. Each one of the 4 parts between with the dots in between could be up to 3 digits from the number 1 all the way up to the number 255. So now that everyone has an address, then when we send around a message, even a message as simple as ABC123, which used to be a lot simpler back when this internet, these wires were simpler, we could just send to each other ABC123. But now we have to do something a little bit different. We have to start off by saying, I am 100.200.211.68. I want to send this to 111.222.101.44. And what do I want to send? Okay, now I can finally start telling you what it is I actually want to send. I just want to send them a message saying, hello, what's up? Okay, and now this entire message is going to go over the wire, and it's going to go through some programming that figures out, oh, where does it need to go? At this juncture, if we want to reach the address of 111.222.101.44, this is the wrong way to go, and in fact, rather, this is the right way to go, and we reach the right address, and we finally give them, we toss away this whole part at the beginning, because this was just like the preliminary stuff to find our way, but now that we found our way, we're in the right place, okay, so let's just pass them the message, and now they receive the message on their computer, and vice versa. Anytime some people are sending messages to each other, you have to first give some identifying information, where you're coming from, where you're going to, and then hopefully your message will find its right way across all of these wires to find their way to the destination where they're trying to come. So what we've learned is that the internet is basically just an innocent attempt at sending and receiving stuff between different computers. That's all that it is. That's all it ever was, and that's all it continues to be until today. So there's a lot more layers to this, actually. We can keep going on the whole history, piece by piece, how this all happened. Oh, so how am I supposed to know if this guy's address is this number, if this guy's address is that number? How am I supposed to know who is who? It's hard for me to remember 123.233.196.67. That's the University of whatever. But 111.222.101.44. That one is the White House. And 100.200.211.68. That's the science lab where we first invented this. So how are you supposed to remember all these names and these numbers and where those destinations are? It used to be back in the beginning, people used to actually keep lists. They would keep files with lists of like which person, you know, which address, which location, which organization, and what is their IP address, what is their the number that reaches to their systems, to their computers. But after a while, they realized they have to systemize that. So they made a whole system where there's a central computer that everyone jointly uses together. And that central computer is in charge of taking something identifiable and turning it into an address. Like, it's hard for you to remember the address 111.222.333.444, but it's easier for you to remember University of Texas or White House. So if you gave this machine the words White House, it would give you back, oh, you want White House? Okay. Their address is 111.222.1. It was kind of like an address book. It was like a directory. So that was something that eventually became known as the domain name system. And now any website that you have, like google.com, facebook.com, all of those names are converted into IP addresses of a website you're trying to go to. And there's more layers about that. When you send a message across the internet, it doesn't exactly go perfectly just like that. Sometimes it gets chopped up into different packets. And first, one packet goes ahead with one part of your message, and then another packet goes ahead with the other part of your message. And sometimes they could take even different routes. The first packet might go through one whole spaghetti of wires across this route going all the way to the destination computer. And sometimes the other part of your message is going to take some other route because it thinks that it's a better route to go some other way until it finally arrives at its destination. There's a bunch of different layers over here, but I'm just going to simplify it a lot. You guys don't even need to know most of that. There's a lot more layers to it. Complication on top of complication. There's a they call it, what is it? The 7 layers of networking. There's a level 1 networking, which is the physical wires. And there's a level 2, which is the electronic signaling. And there's level 3, which is domain names and IP addresses. Then there's level 4, which is packets, and level 5. And finally, by level 6 or 7, you actually get to an innocent guy just trying to browse to a website on his phone. But I'm getting into way too many of these complications. At the end of the day, the bottom line is the internet is a bunch of computers that are trying to send and receive stuff between each other. That's all that it ever was. That's all that it continues to be. It's as simple as that. Because a lot of computers around the world want to send and receive stuff between each other. So we need to come up with a few systems about how that's supposed to work. Everyone needs to have an address of where they can be found. Companies want to sell internet services to people, so they take kind of like a chunk of an area where they have their service, and they install wires to people, and they charge them money for it, and they connect them to the other wires of the rest of the world. That's how people buying internet service from a company can now be connected to the rest of the internet of the whole world. and how domain names get changed into addresses. There's a bunch of different systems that need to be put into place if you think about it so that it could work. But altogether, all you're trying to do is your one computer, you're trying to exchange some information with another computer, and that's about it. And in fact, you guys may have heard of something called a server, right? When you have a website, oh yeah, it's something on the server, the website is on the server. What's a server exactly? And why does it sound so complicated and like seems so scary? So it's not that scary at all, actually. At the end of the day, the truth of the matter is, you have a computer at home, that's something that you do understand, right? That's something you are familiar with, a laptop, a computer, that's simple enough. Guess what? A server is basically a computer. End of story. A server is a computer. So you know what? So it looks a little scarier. Maybe it looks like a tower computer, and it looks like it doesn't have any screen because it doesn't have people sitting in front of it to use it. It looks like this big box with a lot of, you know, all the machinery going on inside of it and a lot of wires coming out of it. But guess what? Your computer has a hard drive and the server has a hard drive. Your computer has files and folders. This computer has files and folders. Your computer needs to be turned on and it deals with information and it runs programs and all sorts of stuff like that. And so does any old server on the internet. All they are basically a computer. Your computer at home is a computer that's customized for a human to use. So it has a nice keyboard, it has a nice screen, you can plug a mouse into it. You have a graphical operating system like Windows or Mac that you can use, and you can click buttons and you can open up programs and listen to music and play videos, right? That's how your computer looks. And the server is also a computer. It happens to be a computer that's customized and specialized in order to be just a machine in a closet. So no one's going to be looking at its screen to see what it has on its screen. No one needs to type anything into it with keyboards. It doesn't need to move around with a mouse. So it's a computer just like yours. It's just that it doesn't need all the things that your computer needs. Yours is used by a human, so it needs all sorts of peripherals for a human. And the server is meant for the, you know, for the closet. And they have these huge data centers somewhere across the world. They have a lot of these data centers everywhere across the world, where they have basically just like a huge storage room full of servers, full of computers that are basically, you know, servers that are basically just plain old computers. Let's have a quick peek a little bit at what these data centers look like. And yeah, I don't even know if these are realistic. These look like they're from the movies or something. I don't even know if this is actually how they really look. But the concept is something like that, where like you just have racks upon racks upon racks upon racks. This one maybe looks a little bit more real. You know, you have just like hundreds upon hundreds, thousands upon thousands, really, of computers. That's all there is. They're just a rack over here. There's a shelf that has on it the hard drive, the CPU, the RAM. It has the plug that goes into the internet plug. It has some nice flashy lights to make it look fancy, but it's basically trying to tell the maintenance people, is it running? Is it functioning? Is it online? Is it working? And it's basically just computer, 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 computer. Thousands upon thousands of computers. So we learned that the internet is one computer trying to exchange information and get stuff from another computer. And when you're browsing on the internet and you're going to websites, that's basically what's going on. So let's actually walk through the story of what happens when you, let's say you open up the browser and you open up a tab and you say, bring me to facebook.com. So let's go through the story of what just happened here. And it happened here really quickly, instantly, within a second. But actually, a lot of stuff happened behind the scenes very, very quickly. So let's go through that story a little bit. Your computer has a program called a browser, and you open up the browser. And in the browser, you typed in the address, facebook.com, and the browser knows what to do. The browser tells your computer to please send this message out to the wild blue yonder. Send it out to the internet. What message did we send out to the internet? Something to the effect of, hi, I am me, which let's make this a little bit larger. So it starts off with something like, hi, I am me, which in computer lingo might be something like, what is your IP address, basically. So blah, 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 blah. Okay, and then it says something like HTTP 1.0 1.1, I guess, by now. Get, and then it says slash, and then it says host facebook.com, and maybe a few other things I don't remember exactly. Maybe something like date, and it puts the exact time when this request started, 8:33 p.m. Eastern Daylight Time, whatever, and a bunch of different things of this sort. Okay, so as you can see, from back in 1969 or whenever it was that they started the internet until today, things have gotten quite complicated. There's a bunch of stuff that we send over here before even like making sense of what speaking any actual English. So, right, we're telling the internet, I came from this computer located at this internet address, and I would like to place a HTTP request. It's a kind of fancy way of saying I'm going to be requesting a web page. Why do you have to say that? Well, because guess what? There's a lot of different servers out there and a lot of different computers out there that want to talk to each other in other languages about other things. For example, maybe you're going to send out a, let's quickly show, for example, maybe you want to send out a SMTP request, and that has to do with, or maybe I'm remembering it wrong. Is it maybe RTSP or RTMP or something? One of these most recent protocols of how they stream videos, right? If you're maybe part of your website is you're browsing to a YouTube video or something, and it's going to start playing a video, or maybe you open up some sort of other program on your computer which gets you video from the internet. Like maybe you have some sort of webcam security system or something. Then you might not be that's not browsing web pages, right? That's requesting for some video stuff from some server that's giving you video stuff. And that's not using the HTTP protocol, that's using RTMP, the remote media transport protocol, something or other, whatever it is that it is. And other people might want to talk in VoIP language, right? Because you're placing a phone call over the internet, and you're using that kind of protocol and that kind of thing that you're trying to communicate over the internet. So there's a lot of different things that could be flying around on the internet. Right now, though, you're a computer, your computer has a browser, and your browser wants to talk about websites. He wants to get a web page. So he's saying, I'm going to be asking for HTTP. HTTP stands for Hypertext Transport Protocol. It's the kind of protocol that people have agreed upon, that people have standardized in order to talk to each other in terms of HTML pages which might have in them CSS files, and they also might bring in some JavaScript and all that sort of thing. I am a browser. I want to browse to some pages. That's what the HTTP part means. And if you ever noticed a website that has HTTPS at the beginning rather than HTTP, that just adds the word secure or secured to the abbreviation, because it's a more it has encryption. It basically secures your communication by encrypting it so that people can't really see what you're browsing or what you're sending and receiving to each other. So if people want to talk in an encrypted, covered up way that people theoretically can't see in the middle what's happening, we can talk about that at a different time. It's not that important. But basically, you're asking out to the internet, I am looking for a web page over the Hypertext Transport Protocol. And it happens to be that there was like a version 1 of this, and then there was a version 1.1. Actually, these days, many of the browsers are already talking in HTTP 2.0. So that's just a version of the protocol. You know, if you're an older version, then you might not have all the specific features of this version. So you have to specify which version you're talking about. And finally, you're saying the command. My command is get. Later on, we're going to learn about other commands. You can do post, which is when you're sending them information. Right now, though, all you did was you typed into your browser facebook.com. That's not really that you're sending them some information. If you fill up this sign-up form, for example, and you're going to be sending them your first name, your last name, or if you're going to be using the login form and you're going to be putting in your email or phone and your password, and then you click login, or then you click sign up, that is actually going to send not a GET request, but rather it's going to send a post, because this is the way how to tell the computer, I am sending you some information. Here's a first name and a last name and a password and an email and whatever it is. That is the post command. But in this case, when we typed in just facebook.com, we just requested get. Get me the hypertext transport protocol stuff that comes out of my request. What is your request? I requested for the host name facebook.com, because I don't know the particular machine, the particular server where facebook.com exists. I don't know what address that is. Maybe it's 111.222.112. Maybe it's a completely different number. I don't know what the number is. I can't be bothered memorizing what the number of the address of Facebook is every time I want to browse to it. So I'm going to be taking advantage of the DNS, the domain name system, which is basically that big directory computer, where I send you a name, a word, an identifier, and you find for that the address, the number address of where this computer is located. So I'm sending out to you facebook.com. Please go find for me how to find the address of facebook.com and go and request for them a page from that system. Which page are you requesting? Actually, in this case, we only had slash over here. Slash basically just means the home page, the beginning. If we were going to facebook.com, let's click on a link over here. So we go into some other page. Create a page, maybe. Why is that loading too long? Facebook, you're supposed to act quickly over here, and especially since I'm right now on the internet with people watching. Okay, here we go. So now the internet address is facebook.com/pages/create with a bunch of other stuff. In that case, your request is going to look a little bit different. You're going to ask for get/pages/create. But in this case, in our first example, we just wanted to go to facebook.com straight up, just Facebook plain. So that's just expressed by putting a slash over there. By the way, this is not perfect and exact over here. I'm kind of just illustrating. It's something akin to this. It's something like this. But if you guys want to look up the precise language of HTTP, how you're supposed to type out the request, I don't even think you write the IP address at the top. I think that's not even at the HTTP level. That's like 1 or 2 levels deeper by the packet level. That's when you send the IP address. So it's not even part of this HTTP request. But whatever, you get the idea. We have to identify ourselves where this request is coming from. We're saying, I want to get hypertext transport protocol stuff. I want to get the page that's at the root, at the beginning of the website. Of which computer, which server out there on the internet? Well, whatever you find when you look for facebook.com in the big world internet directory. That concept of the domain name system, the big phone book where you give them a name, a person, a organization, which in this case, by this point, it always has to be some sort of website name like something.com, something.net, something.org, or even more than that, something.something.org, like, for example, www.facebook.com. Or if any of you guys use WhatsApp on your browser, so then you go to web, web.whatsapp.com, right? So that all of that is part of the domain name. All of that is part of the name, the organization, the identifier of how to find what that website's address, what that website's number IP address is. And then finally, some additional information like when did I start this request? You know, if a server ever for some reason out there gets a request like 7 days after it was sent, it might decide to be a little skeptical as to whether it should try responding. What took you 8 days for you to send your request for it to get to me? Did you take a horse and wagon to get here? And it might reject the request and not try to find it for you. But you identify when was this request sent out, and maybe a few other pieces of information, which I don't remember right now, but this is basically what happens. Your browser takes all of this stuff, and it sends it out to the internet. So this stuff starts going out on whatever wires come from your house, And it might be wires and might be not wires. It might be wireless. That's a new technology that they only invented sometime later on during the advent of the internet. So either this whole message is going to start going from your LAN wire to your router, and from, oh, I changed the background color over here. From your computer through the wire to the router, and from the router out to the coaxial cable that the technician installed at the back of your house to the wire on the electricity pole outside, which might go down in the drain under by the manhole over there, which might connect to a central hub somewhere a few blocks away. From there, it might connect to another bigger hub somewhere in Manhattan, and from there it goes out to the world, and it goes that way. Or if you have Wi-Fi, then they figured out how to make this cool technology that without even having a wire, your same request could head on out there without even being connected with a wire. And let's just try to be cool here for a minute and make the little radio symbol. And it pretty much has the same effect. It's just that it didn't need a wire to get there, but it basically sends the signal out to your router, and from the router it goes to the coaxial cable, to the electricity pole, to the manhole, to the nearby connection, to the hub, to the central data center, and from there to the domain name system, etc. But the idea is that this message goes out there to the wires, and it starts looking around and asking, where can I find my nearest, most convenient address book? The DNS, the kind of directory concept that we mentioned about before. Let me just write this over here. DNS, which stands for Domain Name System. And all that it is basically when you tell the domain name system, what's the address for facebook.com? And it looks it up in its directory. And I don't know why it did that. I still don't know why it did that. Oh, probably because this is this. Okay. Anyway, no, not for that reason. Someone probably knows what, oh, because this thing over here. There we go. Okay. Anyway, point is, oh, and also this is not the correct way. I'm pretty, I'm much better at Paint than I am at Photoshop, so excuse my very amateur skills here with graphic coloring and stuff. Anyway, you give the domain name system a name, and it gives you back in return an address, a sequence of numbers, 123.456.789. Whatever. And now your request continues on. It converted the name into an address. So now we have an address. Okay, so now that we have our address of where we go to, we're going back out to the wires of the internet. We're going to keep going around, jumping from one place to another, from one big hub of the internet to another. This time, we're not looking for how do I find the address that I'm looking for. Now I'm asking for directions to this address. How do I get to 123.111.222.190? By the way, just for fun, why don't we go ahead and look up the actual address? I'm going to open up this page over here. I'm going to press F12. Oh, that was F11. I'm going to press F12 to pull up the developer tools, which I'll zoom in on a little bit here, so hopefully it's visible enough. And now we're going to discover another tab. We've seen the Elements tab, the Console tab a little bit. Oh, guess what? Even Facebook has some errors on their page. Okay, you know what, guys? As you're practicing and trying to make sure your code is perfect and everything works correctly and all that, well, guess what? You should know that other very professional websites out there, okay, they have problems on their website as well, and they have errors, and they did not fix all of their errors. And they're relying on the fact that, guess what? It still works. It's okay. So nobody cares if there's an error or two. So keep that in mind. Sometimes you just got to get something going, and you can't get too stuck on everything. But for good experience and good programming practice, it's very important to get used to, as much as possible, learning, understanding what you're doing, and try to avoid any of the errors. But anyway, we've seen a little bit of the sources tab, and we're going to do a little bit more on that when we recap and go back into some more JavaScript. But now let's look at the network tab. The network keeps track of all of these communications that you have with the internet. that you send out a message, give me this, and you actually got something back, as we're going to discover on the rest of our journey. So I want to find out from when we load up Facebook.com, I want to know what is Facebook.com's actual IP address. So I'm going to monitor the network tab, and I'm going to refresh the page. Now there's a lot of stuff that's coming here, but I want to see just the doc, which means just when I request a page, when I request a document, that's the only ones I want to see. There's a bunch of other stuff happening, but I just want to see requests of documents. And I see here the first one, I scroll all the way to the top. The first one was to the document of Facebook.com. And it has over here all the details of our request. I'm going to click on it. I'm going to go to the first tab over here, which is headers. And here we can actually see that geeky behind-the-scenes HTTP message that we're sending out to the internet. I wonder if we can see it in its raw form. Raw HTTP request. I'm not sure if we can, but this is as close as we can get. We see the request URL was this. The request method was get. The response code that we got was 200, which means success. We're going to see about that a little bit soon. And finally, here we go, remote address. After we went to the domain name system and we found what Facebook's IP address is, it came back with 31.13.71.36. That is actually where, this time when we browse to Facebook.com, that's the machine that you reached. By the way, I dare you to keep monitoring every day. Try to go to Facebook.com today and tomorrow and after tomorrow and compare the IP addresses. I don't think you will always get the same IP address, which is another layer of complexity. The fact that when you go over the internet and you send a message out there, sometimes you might end up at one computer, and sometimes you might end up at another computer, even though both times you requested the same page. And why is that? Because Facebook has a huge website with a lot of people browsing to it, and one single computer cannot possibly handle millions and millions and millions and millions of people browsing it all around the world. You have to come up with some solutions for this. So they set up a whole bunch of computers, a whole bunch of servers that are going to be working for the Facebook website. And each one of them technically is on a different IP address number. They have a different location where they're located. So depending on the load balancer and the router and different layers over there about how it works, you might one day end up getting your page from one computer, and another day you're going to end up getting your page from a different computer. Once it's going to be from this IP address, and another day it's going to be from a different IP address. So if you want, you can monitor that and see how if that's correct or not, and how that works. And then there's a bunch of other stuff over here which we're going to get into. But we saw a little bit of how it works. To when you type in Facebook.com into the browser, it sends out a GET request over the HTTP protocol. It has to find what the address of that machine will be. And then finally, it's still going around and it's trying to find where's this machine for this address, which in our case, we're looking for, where do I find the machine that is at address number 31.13.71.36? I wonder if this literally works as is. What if I do that? What if you browse directly to 31.13.71.36? Will that actually work, that you can browse to the web page like that? Or it only works if you type in a Facebook.com name? Because usually this should work, but let's try this out for a second. Oh, well, it did work in the sense that it redirected me. It told me, oh, you put an IP address of Facebook. Okay, so you know what? You can't go straight to the IP address, but I'm going to redirect your browser. You don't want to go to this IP address. Instead, just switch it, go to this actual web address instead. So he made my browser redirect to another location. Anyway, okay, so we type in the address in the address bar. The address goes out there as a request and says, where do I find the IP address for this name? And someone out there responds, oh, I got a DNS over here. He found in the big directory that for Facebook.com, you want to get this IP address. Okay, thank you very much. Now I'm going to find my way to that IP address. You're going around traveling between wires and buildings across the world until finally you arrive at one of Facebook's big data warehouses, where they have all of their stocks and stocks of computers over there, all of their servers. and it goes inside of the building somewhere through the wires, and the router over there says, oh yeah, this time go to this machine over here, or go to that machine over there. It jumps through the wires to a specific machine, and it arrives at the server that is going to respond to your request. So we're only halfway through the journey over here. You sent out a message saying, I would like to have facebook.com, please. It found the address for us. It reached the computer. But now we have to go through the whole journey of it doing whatever it does on that computer and coming back with the response. So actually, while we're talking about this, I wonder if there still is out there. We're not going to watch through it right now, but I'd highly recommend you guys check this out if it's still out there. Journey of a Gmail message. And here we go. This at least used to be, okay, so now it's a video. It used to be an interactive thing that you can play around with. But it's this interesting little animation that shows you what happens when you click send and you send an email, and it starts going through the wires, and it goes through the electricity poles, and it goes through the first routing center, and from there it starts goes through some security checks. So this video is actually specifically about Gmail and sending out emails. It's not about the whole internet and about browsing websites. I'm more than certain there are some awesome video clips out there that explain this with an animation, with a illustration about what it's about. But this one I remember specifically about Gmail. It shows about how things go over the wire, and they get scanned for stuff. And then it goes through another location where they do some other checks. And then finally it arrives at the big data center, and it locates the specific machine where your mail is supposed to go through. And then from there, it has, okay, whatever, you get the idea. It arrives at some big location. And all this to say basically that when we requested for the facebook.com website, and at some point it actually reached over there, it came to their warehouse, it came to a certain machine. Now it's on a specific machine in their warehouse, and it's going to start trying to answer your request. You requested facebook.com. We finally found the representative, so to speak, that's going to handle your request, and we're there at that machine. So what is that machine? We're calling it a machine. We're calling it a server. Remember, don't get too scared. It's really just a computer. It's a computer just like your computer. In fact, did you know that you can turn your machine, you can turn your computer, you can turn your laptop into a server? Yep, you can totally hook up your computer with a wire to the internet, or even over Wi-Fi. And if you set it up to be turned on, to be powered on 24/7, and you set it up with different things that it needs to have in order to be able to do this, but you can totally turn your computer into a server that people can go out there and say, how do I go to Mr. John Doe's website? And it's going to arrive at your IP address of your machine, of your computer, and it's going to do the whole server website thing on your own machine. So all this to say that these are just computers. You have a computer, and over there in the fancy, cool data warehouse, it's just computers. So your request came to the computer, and the computer over there wants to be nice enough to answer your request and to serve you what you requested. That's why they often are called servers. And you are often called a client, because you're like a customer. You're like, can I please have this service? And the server out there is happy to serve you, to respond to your request. That's the whole idea of a server, is that it's turned on, powered on 24/7, just sitting there waiting specifically for the purpose of people requesting things from it, and it responding to them and answering the requests. So the server now is a computer that gets a request. Someone out there asked for facebook.com. What do I give him? So let's start simple. Just like we used to do on your computer locally, like this website over here that we wrote in our own file, in our own webpage, on our own website, in our own computer, on a local file. We save the file locally to our computer, something.html, and we open up in our browser. And it's basically just a file. You open up a file. So let's start simple like that. When you request facebook.com, let's say for now, what you're asking is for a file. Give me a file. Give me an HTML file that is supposed to be the one that you get when you browse to facebook.com. When you browse to facebook.com, something else, or slash one of these other pages we went to, right? Then it might be a different HTML file with a totally different set of stuff on that page and different buttons and different stuff, right? But when you go to facebook.com, give me whatever HTML file I'm supposed to be getting when I go to facebook.com. So think of it a little bit as if browsing for files in a folder in a way. If you ask for the file that's right at the beginning, in the root, in the beginning of the folder, then it's going to look around for, okay, what's the main HTML file that I'm supposed to give him from the beginning, from the root of the folder. And HTML is often configured that if you have a file called index, that's just how they usually make it, index.html is often the default, the main configured file that it's looking for. So it's going to look at the beginning of your folder and try to see, oh, is there an index.html file? That's what this guy wants to have. And in that HTML file, who knows what's in there? Probably everything that puts together this page over here. If we inspect the elements over here, we see, you know, HTML tag, it has head, it has script, title, it has body, all the stuff that goes on this page, right? If I put the highlighter over here and I go to the sign up, you know, you'll see over here, it's a H2 with sign up in it, right? This is HTML that someone wrote. Some developer out there from the company Facebook sat down and wrote an HTML file, which gives us this page and the way that this page behaves and the way that this page looks. In fact, I can look at the other part of the page. I right-click it, and I click on View Page Source. And this is hardly legible because it looks like it's compressed HTML. But you can just barely make out a little bit over here. At the top, it starts with the doc type HTML, and it opens up the HTML tag. And sure, everything is kind of scrunched together, and it's hard to read it. But this is basically an HTML file. So think of it this way. In the machine that resides at the under end of the tunnel when you look for facebook.com, that machine has a folder. That folder is dedicated to be the facebook.com website folder for that particular machine. And in that folder, you have a file, index.html. Maybe it's called something else. Maybe they configured it to have a different name. But let's say by default, they usually call it index.html. And when you type into your web browser, I would like to have facebook.com, it goes all the way to that machine, wherever it reaches. When you look for facebook.com, it goes into that machine's folder, and that machine, that computer says, oh, I know what I have to do. When I get a request for facebook.com, I'm supposed to be giving you this HTML file. So here, copy index.html, and of course, we're going to leave it there. We're not going to move it away or delete it. Other people might need it again soon, but copy the index.html file, and send this back through all the wires to the IP address of where this request came from. Someone asked for facebook.com. OK, take this HTML file, take it with you, and send it wholesale, the entire package deal, send the whole index.html file back to whoever asked me for this facebook.com website. And so it travels back through its whole journey, through all the wires, bringing you back to your browser the HTML file. And it's time for me to hop away. But as you can imagine, your browser sets up the whole page, starts making it look this way, and then the rest is history. It pulls in also some CSS files, some JavaScript files, etc., etc. We'll delve into that just a little bit more soon. I'll be hopping up. Thank you, Label. Nice to see you, and I will be back momentarily.
All right, very cool. So it looks like we're getting into the concept of the server side. So first of all, I just wanted to mention, you know, when we started this, there were like 100 people that started. I was convinced that, you know, by the time we'd be at lesson 2 or 3, we'd already be down to like, you know, 5 or 6 people. So the fact that there's still quite a few that are sticking it out till the end is very impressive. It shows that there's a thirst for this industry, and that's a good thing. It's a great industry, and these are great skills. So I'm very happy to see that so many are still involved. That's amazing to see. All right, so I'm just going to refresh in my head what we more or less learned till now, where we're holding, and feel free to ask your questions. So we learned about HTML, the structure of the page. We learned about CSS, the design, the look of the page, and then we learned about JavaScript, how to actually write with a, so to speak, real programming language that does actual stuff, that does dynamic logic. We learned, from what I could see, how to manipulate the page with JavaScript using a library called jQuery. The way that works is you go and you select items. Every HTML item has some kind of attribute, whether it's an ID or a class or multiple class names or other attributes. So you go ahead and you select the item. By the way, little spoiler alert, I don't know if Yisrael mentioned this yet, but the way the browser actually works is it turns the whole HTML into what's called the DOM, the Document Object Model. And basically it turns the whole HTML of the page into like a big JavaScript object. So what happens is when you want to then look for a specific item, you're really just getting an object. But anyway, that's just a side point. So we learned how to manipulate parts of the page with JavaScript, and now it seems like we're getting into the concept of a server, right? So until now, we're just doing things in the browser. You know, we have technically your internet could have been completely off for what we were doing up until today's class. I'm going to repeat that. Technically, your internet, your Wi-Fi, you could have had zero Wi-Fi connection and have done all the work that we did up until now. But now that Yisrael is getting into the concept of a server and the concept of getting dynamic data from another server, from another computer, in other words, we talked about DNS and going to Facebook and, you know, how the data travels through by looking up an IP address, etc. So now is really a shifting point where we're starting to understand what the web is and how to make requests to other servers to get the data that we want. So that was just a quick recap for myself and for everyone about what we did until now and where we're going from here. All right. Can I make sure I'm sharing my screen? Unfortunately, since Yisrael is still sharing his screen, I cannot, and I was not made the host. So I will not be able to share my screen, but I guess I won't really have much to share. I'll just speak instead. How many people are still participating? We're in the upper 30s. So I think that's still amazing. We're already, you know, more than halfway through the course. So that's very nice to see that so many people are still involved. All right, feel free to ask your questions. Otherwise, I'll go into explaining a little bit the request response concept. I know Yisrael has explained some of this and will continue to explain more, but I can recap. I didn't hear the whole class up until now, but I can recap the general concept. I actually have a little article I wrote up about the request response concept. I think it's very simple to understand, and I will post it here if it helps anyone. I'll make sure to send this to everyone. And it's good to know now that we're getting into this concept of request and response. So if this helps you, it's a very, very brief explanation of the concept, and hopefully it helps you. All right, Q&A. The remote IP address had 123.122.123.123 and then 433. What does 433 represent? I believe 433 represents the port. So for example, if you wanted to, all right, so here, for example, if you wanted to spin up your server at localhost, I can't really share my screen, but Yisrael started to talk right when I got on about the concept of using your own computer as a server. And the way that works is you have to spin up a server. By spin up is just geek talk for make the code, run, and have the port start to listen for requests. Yes, I can type things in the chat as I say. I believe I sent, the only thing I sent so far was one link. So I'll just type some things in the chat. All right. So the question was, again, if you can see, I think you can see the Q&A. The remote IP address at the end has a colon. It has the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers, and then colon, and then 433 at the end. So without looking this up, I'm not 100% sure, but I believe the 433, the 433 equals the port. And the port means the port, so computers have different ports that they can listen on. You only see your own questions in the QA. Okay, I didn't realize that. So I will paste the entire question into the chat. That was the question. So the remote IP address and then 433. So for example, if I wanted to run my own server on my own computer, I wanted to test something, or very soon you'll see how to spin it up on your own computer. You'll use something like localhost, and then you'll have a port, either localhost 3000 or localhost 8000. At work, the localhost that I use generally to test, this is just the way they set up all the environments, is localhost 80, I believe. So there's basically a bunch of different ports. Your computer has a bunch of different ports. And what is a port? And I will post this link. What is a port on my computer? Give me 1 second here. Port number. Port number, localhost. You can also Google the concept of localhost. It's a good thing to know about. What is the whole point of localhost and ports? All right, let's see. Here we go. And I will post this to you. All right. You can click links at least. All right. So you can feel free to look up the concept of localhost. I'm jumping a little bit ahead here because you asked the question, but you'll see very soon in either this class or the next class, once you actually spin up your own server, you will be able to actually use this concept of localhost and have the concept of a port at the end of it. So I believe that's the answer, but feel free to look it up. Did anybody get a chance to read that little post that I sent about request and response? And if so, did you have any questions or feedback? All right, so then I might as well go on a little bit more about this concept of the server and what it means and how you build one. So Yisrael was talking about how, hey, when you go to Facebook, how do you get the data? So what happens when you go to facebook.com? He showed you the whole thing. It goes through the DNS, and it looks it up based on IP address. And finally, it hits the actual machine, the actual computer, which is basically just a server is just more or less a computer that has a listening port, which, generally they don't have screens or whatever, but the idea is it's just a computer that's connected to the internet. And then it hits Facebook's server, Facebook's computer, and it will then respond based on your request. It will say, oh, your user ID or your email address is labelhack@gmail, or his user ID is 1234567 Go ahead and grab the whole profile and all of the friends and all of the posts and all of the images and all of the videos for labelhack. Now, a couple questions that might come to mind. What's the server? What language is it written in? What kind of database are they using? Where is this data coming from? So, more or less, a server is just some code that's running on a machine that's listening for requests and that can respond to requests. So there's different popular programming languages that are used as servers. Generally, you wouldn't just write a program like in a file, hey, here's my program, listen on whatever. In order to do that, you would have to write the code that makes the port open up and listen for requests and respond to requests. So generally, you would use some kind of framework, and every popular programming language has multiple frameworks that are used as web servers. So as an example, again, this is jumping a little bit ahead, but I'm trying to give you a general overview. Since we know about JavaScript, JavaScript can actually be run on the server side as well, not only in the browser. JavaScript can be run in a server, and generally it's done through a framework called Nodejs and Express. And so Node.js is just the JavaScript program that runs on the backend on the computer. There's actually a lot of programs right now that use Node.js. Probably if you're using like a WhatsApp desktop or something, that might be running behind the scenes on like a Node.js. In other words, your computer probably already has Node.js installed. But either way, now the thing is, so Node.js is what allows you to run JavaScript on a computer, not just in a browser. Node.js is called a runtime, a JavaScript runtime, or a JavaScript engine that can translate JavaScript and tell your computer how to act based on the JavaScript that's written into Node.js. Then there's generally some kind of framework on top of it that would make it very easy for you to easily accept requests and respond to requests with HTML, CSS, and JavaScript. And usually those frameworks will come with built-in stuff like the request data, your IP address, all the strings from all the parameters from the URL, everything you need to know about, and then you'll respond with all the data. And basically, these frameworks make it very easy. The one that's popular for the JavaScript framework is called Express.js. You can look it up if you're interested. So if you wanted to use JavaScript as a backend, that's more or less what you would use. But that's jumping slightly ahead. So back to, how are these computers even connected, and how do you look them up? So back to you, Sorrel.
Yeah, label, thank you very much. Okay, great. So we are sort of halfway through our journey here about how it works when you ask the internet for a web page, and how it goes around over there looking for an address, and then finally finds an address, and then it goes to this other computer on the internet that's pretty much a computer just like yours, but it happens to be called a server, and it might be located in a big warehouse along with a lot of other servers. And the idea is that someone in the past, someone previously set up this computer, someone else set up this server to be ready exactly for this purpose. And they installed in there a bunch of different things, and they copied over to there a bunch of different HTML files and CSS files and JavaScript files, and they're all sitting there waiting, ready specifically for this purpose. That when someone goes out there and says, hey, give me facebook.com, this computer, together with hundreds of other computers along together with it, and as a little army of customer support representatives of this website, so to speak, they're all sitting there waiting to respond to requests like this. And the requests come in, depending on the website, it comes in by the hundreds, by the thousands, per second sometimes. And you have the whole entire warehouse as one big choir responding to requests. Oh, someone asked for this. Oh, someone asked for that. Someone asked for the other. Okay, I'm going to respond to this one. I'm going to respond to that one. So let's look at one individual machine over here. This machine that happens to be at this particular IP address. Someone asked for facebook.com. Let me look into my files. Let me look into my folder and see what was I set up to do when someone asks for facebook.com. And it opens up some folder over there, and it finds, oh, I have this HTML file, so I'm going to respond with this HTML file. So what he basically does is he starts formulating a HTTP response. So this over here was the HTTP request that came from our computer and went out to the internet. That's what we came up with. And now the server is going to start putting together something of a HTTP response. And it might look something like this. responding from 123.111.222.190. Here is my HTTP 1.1 response or something like that. And maybe it has a whole bunch of other things like date, whatever the date may be. Maybe 1 second passed since we requested it. So he's going to say 8:33:01 or whatever it is. Maybe ideally not even 1 second passed. It's that fast that it was like within the same second it responded already. And he might be in another time zone altogether. So who knows where he may be? He may be at 8:30 a.m. in like China Central Town or who knows what. Okay, China Central Time or whatever. Anyway, point is, he might have a bunch of other stuff. For example, oh yeah, another thing that he has over here is content type. What am I responding with? What am I bringing back to you? There's a bunch of content types that you can be responding to. You can say, I just have some plain text to give you. For example, if someone just typed ABC123 or hello world, like those examples that they were testing around in 1970, whatever, then chances are you might say, I got a response of text/plain. And that's just plain text, simple as that. And the way it works is, I'm just going to move this around a little bit here so I can demonstrate. After you finished all the pieces of data that describe your response, that describe what you're responding with, then you leave another extra space over here. And I'm actually just going to get this out of the way for a second. And let's try this again. Okay. Condensed with space. Okay, this is fine. I thought I had something else, but maybe not. So the way this works is that you leave one more empty space over here, and then the next line you start actually having the content, the stuff that you're responding with, such as, oh, I just wanted to respond to your message, to your request with the response of ABC123, or I just wanted to answer you with hello world, and that's it. And the system already knows that at the top of the message, there's all these technicalities of where you're coming from. Oh, I think I used to have the IP address on top. I'm not sure where that went. Maybe I failed to copy all of it somehow. 123.111.222.190. And then you write the content that you're actually giving them over here. You might respond with something else. For example, you might respond with image/JPEG. And that means that when someone requested you for something, you're responding them with an image. How does that look exactly? Well, over here, you're going to have a bunch of mumbo jumbo that is basically the binary bits and bytes of what describes an image. If you guys want to see a little bit of what this actually looks like, let me try to save this actual file as a, here, let's take this image over here. I'm actually going to save it as a JPEG. Save as. Save as JPEG. Okay, just going to go here, projects, and test1.jpg. You can actually call the file either JPG or JPEG, either in uppercase or in lowercase. Either of those should work just fine. And then I'm going to do a very weird thing, which is I'm going to open up my code editor, and I'm going to open up that file as a text file to see just what the data inside of that looks like. Okay, where was it over here? Oh, no, I actually opened it up as an image. Thank you very much. I was trying to show them the binary version of this. Can I reopen with encoding? They used to have a thing where they reopen it with encoding, but I guess we don't have that option right now. Point of the matter is, oh, maybe we can open it with Notepad. Let's try to open it with Notepad. Open up a JPEG file. with Notepad. All files was our test one. Here we go, test one.jpg. All right, so there you have it, ladies and gentlemen. This is the text, so to speak, of what the contents of a JPEG file looks like. And the reason why it looks so jumbled is because it's not really text for a human to read. It's actually a bunch of computer bits and bytes that describe the visuals of an image. But basically, you would have all of this stuff coming up right here. Here, let me just illustrate. I'm going to copy actually a bunch of this mumbo jumbo here. I'm going to copy out the first bunch of it here, and I'm going to paste it over here. There you go. There you have some bits and bytes that actually, etc., 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 etc. over here that describe an image. So basically, getting back on track over here, someone requests the computer for a file. Oh, sure, I'll give you a file. Here it is. And I have to explain to you, this is a file. What type of file is it? Is it plain text? Is it an HTML file? Is it a JavaScript file? That you respond, you write that in the content type. The content type of what I'm responding you with is an image. What type of an image? This one is a JPEG image. Maybe you can have image/PNG, and then you'll put in a PNG type of image. Or maybe it could be audio/MP3. I'm not sure if this is actually the correct content type for an MP3 file. Or maybe you could do video/MPEG4 or something like that. The point of the matter is that you can describe over here what type of stuff it is that you're responding with. Someone asked me for something, here's what I'm going to give them in return. What type of thing is it, so that they know how to use it, how to open it, and how to read it. So in our case, someone requested for facebook.com. That results in an HTML file. So I'm going to tell you that I'm responding with text/HTML. That is the correct content type for when responding with an HTML. Since I'm giving you an HTML file, which happens to be a text file that you can read in English with Latin letters and symbols and stuff like that. So it is under the text category, but it is the HTML type of text. It's not plain text, which would be just plain, ABC123 type of stuff. This is HTML. It's hypertext a markup language, which has all those tags in it. So you should know to use it as an HTML page. Anyway, the point of the matter is that in this case, the contents of your response might be something like this: doc type, HTML, and then after that, subsequently, we have an opening HTML tag, and we have the opening head tag, etc., 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 whatever it is that happens inside of that HTML file. Because what the computer, which is basically the server, is basically just a computer, what it did was it got a request, I would like to see facebook.com. It looks inside of its own folder. It's kind of like when you open a folder and the file on your own computer, right? Your browser is like, okay, I guess I got to go to this file, to this folder, open it up and show it in the browser. So the same thing the server does over there. Someone asked me for a file. Let me go to the folder, and I'm going to look for that file, and I'm going to open up that file and give it back to you. So it's a little bit like browsing around for files on your own local computer, except it's on someone else's computer that has been specifically configured to give you files. So you're asking out there to the internet, hey, give me facebook.com. And a computer out there on the internet responds with, okay, I'm opening up my folder over here, and I'm giving you this HTML file. That's basically the idea. And it responds all of this technical stuff back to the internet. And the internet goes ahead and it will route itself back to where it came from. Because when you first sent out the message, you gave the right identifier of like, I came from this address over here on the internet. So, why is this not working? Can someone tell me if we're having a video issue again? Am I not sharing my screen anymore, or is it sharing? Are you guys seeing what I'm showing on my screen? Because I can't seem to have my annotation thing over here. Okay, yeah, you're seeing the paint. Okay, I'm glad to hear at least that. So for some reason, my highlighter here is not working. Oh, that might be because I'm editing text over here. So I'm just going to temporarily copy this out of the text file. file so I don't lose this. And I'm going to actually commit this text in Paint. And then hopefully I could have my highlighter. Oh, it's still not highlighting for some reason. One more time. And does this work? Okay, this works. So why doesn't this work? Oh, there we go. Okay, it finally decided to work. Anyways, I was pointing out that we sent out our address to begin with, which came all the way to the machine, so that the machine is going to know where does he have to find his way all the way back to where he came from when the request came in. So now this message over here is going to find its way out there on the internet. Let's get this garbage out of here. This is not a JPEG image anymore. This is a bunch of document HTML sort of stuff. And it's going to take that whole file, all the contents that is inside of the file, and it's going to send that message back out to the internet. Hey, who is it that came from for this request from out there? 129.234.55100, responding to your call now. Going through the wires, looking around. Where can I find that address? Where can I find that address? Running to this wire, running to that city, to the other data center, all the way back to your particular internet service provider and your area, going back to your neighborhood, going back to the main router, down your block, going back to the manhole, going back to the wire, going through your back window into your house, to your personal router at home, and going through the Wi-Fi or through the wire to your actual computer saying, phew, I came back with your answer. You asked me for facebook.com, and here we go. I gave you this HTML file. And the browser, which is designed to do this, takes that HTML file, and it starts working it into the browser, right? He got a whole bunch of HTML stuff to work with, and he starts giving it to the browser, and the browser is going to take this HTML and start reading it piece by piece, line by line, trying to make sense of it, trying to build all the elements. Oh, I see. You want to have a heading on top, and you have the main title, and you want to have some, this is a whole bunch of compressed JavaScript over here. So it looks very messy and not legible. But somewhere down the line, I'm sure we're going to reach some normal HTML, or as relatively normal as you can get. As you guys can see over here, we're inside of a select, which is a drop-down somewhere with multiple options where you can choose the year. Year 2020, 2019, 2018. Let's see, which one is this? I'll bet you it's like the age selector or something like that. Yeah, there we go. Birth date, June 11, 1995. So this select box over here with all these options, that's we just found the source HTML of where it came out of. Oh, and I just lost it because I zoomed out when I was on the other page. But we saw it there. We saw it before. Anyway, the point is that the browser is going to start working with all this HTML, making a nice page out of it. And then something interesting might happen, which is that he's going through the HTML, which hopefully we can view a little bit more neater inside of the Elements browser. This is the same HTML that came out of the page, except it's kind of like the live version that's in the browser. So if JavaScript changed anything around or messed with anything or whatever, different classes or different elements, then that difference you're going to see over here. You're not going to see that in the source. This is the initial file, the way the developers that created that website wrote it. And here we see the version that is actually alive in the web page as it's living, as we're browsing, as it's happening. So over here, we find something interesting. When you go through the head, if you guys remember, when you created a CSS file, when you created a JavaScript file, and you wanted to include, you wanted to connect that your HTML page should have CSS in it. It should have a JavaScript file in it. And you guys did that by linking it in. Let's see if they have some examples of linking in some CSS or JavaScript. Let's go through it over here. Come on, where is your CSS? Here we go. Oh, it has an icon file. There we go. Here's an example CSS. It has a very, very strange file name because they have this organized in this weird kind of coded way, which like that's the way they work with their system. But if you could just barely make it out of here, this file is called .css. This is a CSS file. In fact, I'm going to right-click and say open in new tab. And I'm going to see that the file over here, .css, in the browser. And this is actually a whole bunch of CSS. You can see it's looking for a class, and it's giving it a border and a display flex and height and pixels, and this is a CSS file proper. Okay, so this is interesting. We went through the whole journey of how your computer requested a web page and it got back an HTML file. And inside of the HTML file, inside of the HTML source code over here, we have some additional things to request out there from the internet. See, as part of this HTML file, the browser gets an instruction. Go and get this CSS file. Go and get this icon file. Go and get some other JavaScript file. Here, this one over here, something, something, something .js. So after loading in all the HTML, we get a whole bunch of more things to start bringing in because, hey, HTML is nice. That's the beginning of our page. That's the main part that puts together our page. But as part of our page, we also need some other stuff from you, Facebook. We need to have all of your custom JavaScript that you wrote for this website. We need to have all of your custom CSS stylings that you have for this website. So as the HTML is being rendered in the browser piece by piece, the browser is also going to go out there to the internet and bring in this piece and that piece and the other piece, whatever it is that is tasked to do. Just like when you wrote in your program over here, let's pull in the, let's have to keep doing this. Here we go. Okay. Just like you, when you created a website and you wrote an HTML file, and at some point you wrote, oh yeah, pull in jQuery.js, pull in my main.js, or pull in something.css. And it went and it got that from a different file. Same thing over here, when you go out to the internet and you request a web page, and that web page requests some other stuff inside of it, it has to go back out to the internet and go and look for that. And look, it has its own web address where it needs to go to. It has over here the protocol, HTTPS. This has a whole entire URL of where on the internet you can find it. In fact, this is a link. You can go ahead and browse to this link. That's what we did before when we right-clicked and put it in a new tab. We basically typed in a whole address. Please go to https:// and instead of a normal web address like www.something.com, instead this is static.xx.fbcdn, which I'm guessing stands for Facebook Content Distribution Network .net/rsrc.php with a bunch of codes and stuff and whatever. And it has to basically go through the same process. Let's examine that real quick. I'm going to open up the network tab. And when I click enter over here, we're going to see a request went out to the internet. Okay, so the whole story over here, the whole journey happened again, where I'm sending out a message out to the wires, trying to connect to a computer out there saying, hey, I'm looking for a website that is located at static.xx.fbcdn.net. Please find me the IP address for that. And it goes out there on the internet and it finds, oh, the IP address for that is 31.13.71.7. It's not the same one as Facebook, is it? What was Facebook? Facebook.com was a different machine by a different address. This one was 31.13.71.36. So they're pretty close in address, but this one is at a different location. You see the web page, the actual HTML file is on one computer in one place, and the CSS file is actually located somewhere else entirely in another place. Just like when you guys started using jQuery, your web page was in a file on your own computer, but you pulled in a JavaScript file from somewhere else completely on the internet. You grabbed some sort of Google Libraries link or some jQuery.com link, and that's what pulled in your JavaScript from somewhere else entirely. So the idea is that you start by requesting one HTML file that comes in with one file with a bunch of HTML markup. And then from there, it gets itself a whole big list of additional things that it needs to fetch. Oh, we need to have 10 additional JavaScript files and 13 additional CSS files. Please go out and fetch them for me from the internet. And each one of them goes through this whole cycle again. Get me this file. Get me that file. Get me the other file. Request, response. He's requesting for something. He's getting back something. Give me, please, this file. OK, I gave you back a CSS file. Give me, please, a JavaScript file. OK, here goes the JavaScript file, etc., etc. A bunch of times requesting for different things and getting responses for all these different things. All of these are just messages going around on the internet, people asking for stuff and people responding with the stuff that they were requested for. So the idea of making a website is to type up these files, to type up these HTML files and JavaScript files, and prepare them and set them up on a server somewhere so that anytime someone wants to browse to a website, they can find your files that you prepared. And the way how this works is with something called web hosting. This is not really related so much to our course. Our course is more about programming and about coding and stuff like that. But just to understand a little bit about how this gets actually set up on the internet and how people get to use your code, how people get to actually experience your web page, you go out to the internet, you go to a internet web hosting service, something like either it's GoDaddy or Namecheap or something like that, whatever it is that the cheap ones might be during these days. You look around for a hosting plan. Shared hosting has some drawbacks, but it's very, very cheap. Or you can have a dedicated, you can have your own server basically, where you rent an entire machine out there on the internet that it's yours, this is your machine, and you can put on there whatever files you want, and you can serve people whatever websites they ask you for. And you go over there and you buy a plan for just like $1.44 per month if you buy an entire year. And it's only for the first year, and then the next years it's more expensive. So watch out for the marketing there. But it's pretty cheap to buy a website space out there. And in the end of the day, you get a website account, you get a web hosting account, and you can go in there and start setting up the files for your website. Let's look a little bit at what this looks like. Something like cPanel, File Manager. Let's look at some images of this. Right, this is basically what it all boils down to. You get a folder of files on the internet. That's the idea. You go into this folder over here. I wanted something else. Open image in new tab. This is basically it. You buy an account on the internet where you can put files over there. And you go into your folder here. They tell you, yeah, put whatever files you put inside of this folder over here, public HTML, or it's a mirror folder called www. Whatever files you put inside of there is available for people to browse on the internet. So you go inside of that folder, you create a new file called index.html, you start typing all of your HTML code, and then you save a few more files out there. You make a JavaScript file, you make a CSS file. Maybe you have 20 different HTML files, each of them with 20 different CSS and JavaScript files. And then suddenly you have a website that is ready for people to actually browse. You have to purchase some sort of domain name to go with it, obviously. You know, you go over here to buy a domain name. I want to have awesomewebsite6.com. How much is that going to cost me to have that name? Because people aren't going to be able to remember what is the IP address of your folder of files on the internet. No one's going to remember. It doesn't roll off the tongue to say, oh, yeah, just go to my website. It's 192.168.13.120. Good luck telling people about your website in that sort of way. So you got to find an easy name for people to remember. Hey, just go to awesomewebsite6.com. And you can buy this only for $88.88 per year, probably also just for the first year, but then maybe later it might get more expensive, et cetera, et cetera. Point of the matter is, you set it up and connect it to your web folder, to your hosting account, and now anyone that browses to awesomewebsite6.com ends up seeing the HTML files that you set up and that you programmed and decoded to prepare for this website. And that's what the guys did when they set up Facebook.com. They set up a whole bunch of those files ready to serve anyone who's asking for Facebook.com. They have the HTML set up. They have the CSS set up. They have the JavaScript set up. It's all sitting there waiting for people to ask for it. And then you get it back into your browser. Your browser starts showing you the page. It gives you all the parts of the page that need to come together. If we didn't pull in some of these other parts, your website might look pretty ugly. If you don't bring in all the rest of the CSS and all the rest of the JavaScript, everything might appear very weird. You might end up things not working. You can't click the buttons. Things are missing and aren't working because you have to put the whole web page together so that everything works. It has to bring all the HTML and then subsequently all the other files that come along with it. Let's actually observe this in the browser real quick just to see. I'm going to zoom out a bit over here on the network, and let's watch all of the requests that happen out there to the internet, which again, the internet is just people sending messages to each other. That's all it is. Hey, please give me this. Okay, I'm responding with that. Let me refresh over here. And whoa, it's running and running and running. We have a total of 60 requests over here. Just for going to facebook.com, you actually made 61 requests out there to the internet. It started off by requesting just facebook.com, the initial first HTML document. Right over here, it says this is a document. And you can scroll, you can click inside there and see the request and the response that came. Actually, if you look over here, we can actually find what we were talking about, the content type. And there we go. Content type. When I requested facebook.com, I got back text HTML. And there's some other stuff over here to describe what the encoding is, but that's not important right now. And this is the date when it came and a few other pieces of information over there. But that was just the first part of the story. After we loaded up the HTML into our browser, and the browser was realizing, hey, this page needs a lot of stuff. Look, I have a link tag over here, and the link source attribute is requesting for this CSS file out there at this address. Okay, let's go out there to the internet and find the CSS file. Get the request. The response came. Oh, I forgot to mention, actually, the server sometimes responds. No, it always actually has to respond with a certain code. Oh, it's not the text anymore, so I can't change that. But let's do this over here. The server is always going to respond with a certain code and a little message. Usually, if everything went well, then it's going to say 200 OK, which means I got your request, I found what you're looking for, and here it is. Here is the response. Everything went well. Sometimes you can have something like 500 internal server error, which means that something was wrong on the server and it had a problem. It wasn't able to give you back what you asked it for. Maybe this is bringing up some vague memories you guys have sometimes maybe seen when you were browsing around on the internet, and maybe sometimes you've come across a error 500 internal server error. Or you might get back the most infamous one that you guys have definitely seen thousands and thousands of times, and that is, of course, 404 not found. This error comes back from the server when you asked it for a web page like facebook.com/whatsup, and the request went out there to the internet, and it went out there to that machine, and that machine said, oh, you have a request? Let me handle your request. Okay, you're looking for facebook.com/whatsup. Let me look into my folder. I'm looking to all my files to see where's the file to respond to this request. I don't see anything under whatsup. I don't have anything for that. I have something for the main page for index.html. I have something for /page/create or something, but I don't have anything for whatsup. So I can't find it. So as it turns out, I'm sorry, I cannot handle your request. I cannot respond to it. So I'm going to give you back a 404 not found. Let's try this out right now. I'm going to open up in another tab over here. I'm going to open up also the developer tools, and I'm going to go to facebook.com/something that definitely does not exist .html. Okay, so I'm pressing enter now. And we get a message. This page isn't available. The link you followed may be broken, or the page may have been removed, blah, 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 blah. This is Facebook's 404 page. They actually don't even show the 404 message. But you can see over here, when we mouse over the first message over here, the first request to the internet that went out there, the response came back not with a 200 OK, but rather with a 404 problem. Error 404, which means not found. I was not able to find what you were asking for. So if you guys ever went on the internet and you got this error 404 nonsense and you had no idea what that means and what does that mean, well, now you understand. You requested for something out there from a computer that did not have that file that you were looking for. Sometimes what happens is people have a link to somewhere on the internet of a file that used to be there, a page that used to exist, but then they moved that page or they deleted that page. Something changed on the internet and that link doesn't work anymore. It doesn't go anywhere anymore. So the computer out on the internet, the server, is kind of like looking around, trying to help you, trying to respond to you with something for your request. but it just can't find what you're looking for. It's not there. It doesn't exist. There isn't such a file, something that definitely does not exist, .html. There is no page like that over there. So what am I supposed to do? Give you something else? Give you the main page? So usually the important thing to do is to let people know you put in the wrong link. This link doesn't go anywhere. It doesn't make sense anymore. You have to try to browse somewhere else. This is not the right place to go because there isn't anything there to give you. That's the error 404. But back to the normal page over here. Usually when everything works well, it comes back with a message of 200 OK, which means everything went well. Let's see some. OK, then. Oh, so the idea we were looking at was that after loading up the first HTML page, the HTML page has a lot of other files to bring. It has a whole bunch. These are CSS files over here. Let's see if I can zoom in a bit. It doesn't let me zoom in over here, does it? OK, a little bit too much. Okay, these files over here are style sheets. Where did this style sheet come out of? Whoever asked him to bring the style sheet, you can see over here in this initiator column, index, the first root request to facebook.com, that page is the one that had the request that I need this CSS file as well. So it had to go out there to the internet and get that file. Actually, it happens to be that because we already went to this website a few times, this particular time it didn't actually go out to the internet to get it all the way from the internet. Turns out my browser was smart and he copied already this file locally, because my browser guessed that it might be that I'm going to browse to this page again very soon, and it doesn't want to have to go the full round trip again all the way out there to the internet to get this CSS file. So it saved a copy of it locally. That's what it says over here, disk cache, which means that he knew already that we might need this file again soon, so it didn't delete it right away. After he got it from the server on the internet, he saved it locally, and then each time that we go to the website now, the browser keeps a copy for us so it doesn't have to go all the way out there again. But in the future, you might need to go out there and get the whole file all over again. We get a whole bunch of CSS style files. We get a whole bunch of JavaScript files. See, these are script files. We got some GIF images, some PNG images, fonts that help us show different kinds of text on the page. More JavaScript files, etc., etc. There's so many of these. There was like 60, 61 of these to begin with when we first loaded the page. So just imagine that. When you browse to facebook.com, it's no simple matter. It looks to you like it's smooth and quick and easy and a very cool experience. But behind the scenes, there's a lot of work going on over here. There's the HTML pulling in a bunch of CSS files, a bunch of JavaScript files, all coming from some computer across the internet and some machine somewhere. So it's possible that somewhere down the line, when you're a developer making a website, you might also be asked, hey, you made this very nice website locally on your machine, but now it's time to put it up on the internet. Can you maybe put it up on the internet for me as well? So now you have a little bit of an idea of how that might work, how you have to open up an account on the internet and put up the files over there, and then test it out to see if you connected your domain name correctly to the folder on the internet. And then if everything works well, then it's going to work. When people browse to awesomewebsite6.com, they're going to see the pages that you programmed and that you put up on the internet over there. And that's all that's happening. People browsing to your website are going to be like, I'm just a computer, part of the internet. I come from this address. I am requesting for this website. And the message goes out there through the wires, through all the places on the internet, and it asks around who has the IP address for this name that he's looking for. And it goes to that computer out there on the internet, which might be a server. Chances are it is a server, but a server is just a computer. And that computer has been configured that anytime someone asks for something, he's going to look up for a file, and he's going to find the file, and he's going to send that file back to you. And now you can read it in the browser, and you could click links and go to other places, and maybe some JavaScript is going to come in, and some CSS is going to come in. Anytime that you set up a website to work that way, ideally, if everything works well and everything was set up correctly, then people are going to be able to browse your website successfully and see your cool, awesome page that you made with HTML, with CSS, with JavaScript. And here I'm just going to touch upon very, very quickly one more last little detail, which is what goes into all that advanced stuff we were going to learn about the back end, the server side, the database, and all that, which is as follows. But obviously, we're not going to delve into that, and there's hardly any time left in this class, so we're going to go back to some basics of JavaScript and all that, hopefully in the upcoming class. But let's just finish with this concept a little bit. You see, meanwhile, the way how I described to you guys how a server works, that someone requests for a page on the internet, or they request for an image on the internet, or for a CSS file, or whatever it may be. And then some machine out there, some computer out there responds to that request and gives you what you asked for. But chances are it's not always going to be just a file. We just turn this into something positive over here. 200. Okay. All right. So until now, we've learned that you can ask for Facebook.com, and Facebook.com is going to get an HTML file that was typed up, and it gives you back that HTML file. And this is something that we call static websites. Static websites means you coded the HTML file, you get the HTML file. As opposed to what? As opposed to dynamic websites. Dynamic websites are a little bit more interesting and cooler. What's the difference? A static website, you typed up the HTML for it, and that's the HTML that's there. That's the title that's there. That's the CSS that's there, the links, the images. What it is what it is. It's an HTML file. But think about this. What if you wanted to show something dynamic on the page? What if you wanted to show like top deals and, no, that's not the heading of the site. Here's the heading. Top deals from around the web. And today is, and you want to put something like, okay, well, today is June 11th, 2020. And you're going to save this file on the internet. And your web page is going to be over there, the HTML file. And people that request your website are going to get that HTML file. And they're going to see, oh, look, today is 6/11/2020. Very cool. What happens tomorrow, though? Oh, tomorrow, it's not going to be June 11th anymore. Oh, I have an idea. I'm going to go into the web folder. I'm going to update. I'm going to change. I'm going to edit the HTML file. And I'm going to turn it into 6/12. And then I guess after tomorrow, I have to go back to the file and I have to edit it to 6/13. And then the next time I have to go and edit it to 6/14. Do I have to keep doing this every single day? How can I make it so that this web page will somehow wisely, smartly, and automatically show me what date today currently is? But how do you do that with HTML? HTML is a file. A file is what it is. Whatever you save in there, that's what it has. If you save it with the text to show 6/11/2020, then it's just going to show 6/11/2020. What if I want to show something like the weather is, well, today the weather is actually pretty hot. So let's say the weather is warm. But right now the weather is warm. In 2 hours from now, if someone browses the website, the weather might be rainy. So am I going to have to go to the HTML site? Basically, you need to have a programmer 24/7 editing and updating all the HTML pages so that they write the right text. What about something else? How about if you go to your account page, right? Let's say you made a whole HTML page that shows your name, John Doe, and your phone number, 111-222-3333, right? And you save that in an HTML file for people to browse to. But when John Doe browses to his page, John Doe should see his name and his phone number. But when Marrow browses to the website, he shouldn't see John Doe. Are you going to have to go now to the HTML file and change it so that every time John Doe comes to the website, it should show John Doe? But every time Marrow comes, it should be his name and his phone number, 777-888-9999. How does this work that you make a web page dynamic, which means that depending on the situation, depending on the time, depending on the day, it might show you different things. How do you do that with HTML? HTML, what you type there and what you save in the file, that's what the website is going to show you. How do you make it dynamic so that it changes things? It's different. It depends. It depends who's the user that's logged in. It depends what time it is. It depends what the weather is. That sounds like a job for programming. Programming is this kind of dynamic thing which has if statements, it has variables, it has loops, and it has logical operators, and it has these kinds of questions you can ask. What is this person's name versus what is that person's name? What is the time right now? What is the weather right now? HTML is not really built for that because HTML, it is what it is. What you ask it, what you get it, that's what it is. Whatever you saved in the HTML file, that's what the HTML file is. But with programming, you can change what should be the HTML. If we had some sort of programming way of saying, when I write the name over here, I'm not going to hard code over here exactly whose name. I'm going to code John Doe's name, and I'm going to code Yankel's name. No, how about this? I'm going to put a variable here. Maybe it's going to look something like this, or who knows what. Here I'm going to say name. And then here, let me zoom in a little bit more so you guys could maybe see what I'm illustrating here. This is not exactly how it's correctly done, but I'm just illustrating the idea. I just made some sort of code over here to denote that this could be John Doe, and this could be Yankel Marrow, and it could be Reuven Shimon. It depends. This is going to depend on some logic, on some programming. Whoever the name is, that name should be filled in over here. And then over here, whatever that person's phone number is, that should fill in over here. And now your HTML should try to be dynamic. Instead of whatever you save in the file, that's what it's going to show on the internet. That's what it's going to show in the browser when you browse to it. Instead, now we need to have some programming. And the programming is going to use some logic and some processing to pull up a record from a database, perhaps, and see what is this guy that just logged in, what is his name, what is his phone number. Or maybe let's pull up from the database, what is today's weather forecast? Is it cold? Is it rainy? Or let's look up right now on the clock and see what time is it right now. Is it 6 a.m.? Is it 8 a.m.? Is it any day, any time of the clock ever? And whatever responses you get, whatever those variables have inside of them, that's what gets resulted in the browser. For one person, it's going to look as if you typed quite literally Yankel 777-888-999. Like for them, that's the HTML file that they're going to get. Hey, you asked me for Facebook.com. Well, guess what? Facebook.com has your name in it and your phone number in it. Oh, that's cool. I didn't realize that Facebook.com's HTML file has my name and my phone number in it. That's what it looks like. But actually, it was programming behind the scene that put your name in there dynamically. Also, if you logged in as someone else, then you're going to have a different name over there. John Doe, did you know that Facebook.com's HTML page has your name and number in it? And Yankel is asking, wait a minute, I thought it has my name in it. And John Doe is saying, wait a minute, it has my name in it. How could this be? I thought an HTML file, whatever you save in there, that's the stuff that it has. But with programming, we can make a page dynamic. We can make a page change what it has in it based on who's logged in, based on what time it is. Maybe you have a variable such as current date and time. And then whatever time it is, whatever day it is, it's always going to show the correct time of when the person loaded up the page. And this is this concept of dynamic web pages, that not just what you typed in the HTML, that's literally letter for letter, word for word, what goes to the browser, but you can actually program the HTML that comes back to the browser. You can program what this guy does over here before he responds. It could be that one computer that asks him for a web page, he's going to give you back one thing. And the other person who asks him for the same web page, he is going to do some more programming. He's going to look through these if statements and variables and see, oh, wait a minute. When the guy from the other computer asked me, then I had to pull up this stuff, and I gave him this bunch of HTML. But now this other guy is asking me for the same web page, but he's logged in as a different user. So I'm going to do some other programming. I'm going to look up these arrays, these variables, these objects. I'm going to do some loops and some functions. And the end result is different HTML for each different person. And that's the idea of dynamic web pages that you can program on the server side. until now, we were doing programming that is relevant for the browser. When the page comes in the browser should have the HTML that it needs to work with. It should have the CSS that it needs to work with. It should have the JavaScript that makes the page in the browser come alive and do cool different things. But the server side of things, the back end side of things, is your programming stuff on the server. You're making dynamic stuff happen on the server. That for one person, it might result in one kind of HTML, and for another person, it might result in a different kind of HTML. That's the idea of back-end programming, which we were going to go into, but as of currently, the plan is that we're going to continue recapping a little bit more, going more in depth into basic concepts of programming, which we need to know and we need to be very well comfortable with when we proceed with more advanced topics, if we have time for it in this course. So we're going to recap some more about functions, about variables, about loops, and all those kinds of things, about jQuery, and hopefully with a good, healthy knowledge of programming and dynamic, cool stuff happening, changing variables, changing data. Each time it does a different cool thing based on the situation at that point, it could be a lot more understandable how you can make a dynamic web page that does different things depending on the situation, different times, different persons, etc., which we shall see, God willing, in the upcoming classes. Thanks everyone for joining us again, and looking forward to seeing you guys next time. Please feel free to exercise further all the stuff that we learned, HTML, CSS, and especially JavaScript. If you haven't played around with loops and functions yet, if you haven't played around with arrays and objects yet, if you haven't made your number guessing game or gone through all of the freecodecamp.org exercises, please do go ahead and do so. And I'll be chatting with you guys in the Slack group so we can follow up with how each other are doing and where you're holding. And we'll continue on, God willing, next time. Thank you very much, and have a wonderful weekend.